We are going to look into a new component or new consideration in system or in system design that is called caching. We have seen some of these part in our previous session, but we will just dig into deeper now to understand what are the different consideration when we have a cache in our system. So we have to look at it how exactly different kind of strategy that we use in caching. So we will just revise what we have learned in the past, but definitely we'll get into more details. Going back to our previous sessions, yes, we have learned load balancers, where exactly we put that load balancer, what are the different algorithm that we use while load balancing, and we also seen the redundant load balancer. So that is something another important topic. And now we are moving to caching. Just to inform you, these all topics why we are covering because anyhow what we want when we are designing a system, the system should be available, system should be fault tolerant, and system should be reliable. See, these are all principles that we have learned. So those, how we can achieve those principles, how we can achieve those different scenarios when system may go down or system slow down or anything can happen or system's response or latency or availability will go down. So to achieve those, we have to look into these individual components. So let's start with caching now. Maybe as we move ahead, we will able to learn and we are able to understand that how these components are helping us to get better latency, high availability, and fault tolerance system. All right. So let's revise what we have learned in past. Let me just zoom it a little bit more. Okay. So here first diagram is about cache, and what we have learned through this diagram is cache is a temporary storage, which is in-memory storage. And that usually we use cache between web server and database is to have quicker response to our user. Whatever request coming in, it will first check that response is available or that data is available in cache, and then it will be quickly responded back to web server because cache is faster than the regular database. So to have cache is again a part of system design, whether where you want to put this cache. It may be a different part of the system. Mostly it is closer to the front end of the application so that the front end get a quicker response from cache itself. So here, as I mentioned, it is stored the expensive responses. Expensive responses, what we have seen that if on backend side there are some kind of uh, calculations or some kind of additional activity that you have to do on the database or multiple database, or maybe there is one more web server behind, maybe application server, which do some kind of uh, transactions over the database back and forth, or maybe you have to join the multiple tables to get some particular data. So it may take some time. So these kind of expensive responses, that means the responses which takes time, that usually we cache. And that cache data will be quickly responded back to the web server or to the user. And because it is in memory, the response will be faster. Okay. And as I mentioned, the cache can be applied at any layer. Right now, it is showing between web server and database, but you can find the cache at multiple locations, at multiple places, and there will be not one cache. There will be multiple cache. Cache again, it is a kind of machine itself on which the cache in memory databases are stored. So that it may not be one, it may be multiple. Just like one goes down, another will take care of the caching of data. So that is what we have seen last time. Okay. Similarly, if you look at CDN, Content Delivery Network, it has also the similar kind of purpose, but only CDN is what it is here. It is mentioned geographically dispersed servers. That means if user is located at different location in the world and user is asking for some static data, maybe user want to load particular web page or maybe a particular video. So in that case, whatever static data is available for that website is actually stored in CDN. Whatever latest data is there, it is stored in CDN, and that will be immediately served to that located for that location. For example, suppose here in Asia, if there is a server in Pune and CDN in Pune, and whoever is accessing closer to Pune, they will able to access through this CDN, which is closer to that user. But if it is in Europe, some country, and they are accessing the same website, so they can get that data from the server which is in Europe. So this data that is replicated in CDN is again kind of cache, where if latest data is available, then it will be served. If it is not available, then CDN will go back to the database server. Here in this diagram, what we have seen, CDN will go back to web server to get that latest data and update it itself. Like it will update itself and it will start serving the users. That is the, it is geographically dispersed because these CDNs will be located at multiple servers at the multiple locations so that the closer users will be served better with the latest information. That is one. Again, we have seen last time, it is only static content that is being stored in CDN, not that is changing. Because if change of CDN, if you see that if we are dynamically changing the data continuously in CDN, that may not be a right use case because changing data going in and out from CDN is a costly matter. Because CDN is usually uh, served by a third party provider. So every transaction that is goes in and out of CDN is an expensive for the particular organization who's handling the system. Okay, so here I'm not getting into detail, but as I mentioned in CDN, CDN is located all over the world, especially different data centers, whichever data centers are available. And whenever a particular user is trying to access a particular website, then that user will be diverted to the closer CDN, closer server on which CDN is located. So whether it is Europe, whether it is US, whether it is uh, Southeast Asia or some other part of Asia. So they will be first diverted to the closer CDN, which will serve the static content to the user. Okay. So this is about CDN. But again, as we are looking at caching, CDN is all kind of caching. We are caching the required information so that we can respond back to user quicker. Okay. So that is the whole purpose of it. I included CDN here because it is also another kind of caching that we do. Okay. But there is one problem in caching, whether it is in CDN, whether it is actual cache memory, that there is has to be a continuous sync between the data and cache data which is in database. So user is no is not just reading the data, but user also modifying the data in database. You're also writing newer data. Okay, so there are possibilities that cache may have outdated data because cache is there. Okay, we have written the information to cache, but that data is after some time user has written a new data. Maybe it is written in cache or maybe whether it is written directly in database. Chances of cache having outdated data is more. So what we need to do is we have to clear the cache. We have to, or I can say we have to see to it that cache will have latest information available to it so that it can serve the same data to the user. Okay, so that's one problem. So what we are going to do next is we are going to look at some strategies which will help to see that how we can invalidate the cache. The invalidation means how to remove the outdated data from cache. So here, the first thing that we are going to look at it is cache invalidation to see to it that cache should have the latest information. So there are two ways usually when we read the data and when we write the data. How we can see to it that cache will have the updated data. There are both advantage and disadvantage for each of these strategy, but I'm going to explain you in detail. First, we'll look at the read, but before that, let's look at the definition of cache invalidation. See, caching is important. It's fantastic. It's necessary. So it's required because we want it should match with the source of truth. What is source of truth? Is database. Mostly information is written to the database, and cache should have that latest written information available with it so that it can serve that to user. So if the data is modified in database, it should be invalidated. Invalidate means what? The cache should have that latest information in it, with itself so that it can serve the latest information and there will be consistency. Like user is writing some data and another user is trying to read that information. But if the written information is not available to the user who's trying to read it, then that will be a discrepancy, a kind of inconsistent behavior. So we are trying to avoid that. We're trying to see that how we can serve the latest information to the user. Okay. So we have to do kind of cache invalidation. We have to see to that how cache can sync with the latest information from database. So here what we are going to look at is read strategy. These are two read strategies. And here first name is cache aside. What does it mean? So let's look at this diagram. What it will do, what web server will do, web server will try to read the step number one from cache. Okay. Then step number two is what it is saying, cache hit or cache miss. What does it mean by hit? Hit in the sense the cache has that data, like whatever data web server is looking for, that is available with the cache. So it will immediately send that data. So if the data is available with the cache, it is called cache hit. So it is available. So it will immediately send that data to web server. But if cache miss, that means the data is not available with the cache, it will what it will give a response to web server that data is not available, or failure, or kind of message. Usually when success, we will get message 200. But if it failed, it sends a message to web server. And what web server will do in that case, okay, data is not available with cache. It will go to step number three. It will inquire database. It will send request to database to read the data. And the database will send that data to web server. So till step number four, data is received from database to the web server. And what web server will do after getting that data, it will send it back to user, that's for sure. But it will also do additional task of updating the cache with that latest information. So this when we are doing this operation, when we are reading the data from cache itself. Okay, web server is trying to read the information, and because the data is not available, because the cache miss happen, it will web server will go to database. It is not cache is going to ask database. It is web server itself is going to inquire database, get that latest data, and web server will update the cache. And that is again I'm mentioning this is while reading the information, reading the data. But if you look at the other side, read through cache. I'm just adding a word behind it. That's again another strategy. What in read through cache, what we do, web server will try to read the data from cache. If cache has the data, then cache will immediately send that data back to web server. And that is again, I say cache hit or cache miss. Point number two is mentioned. If it is hit, it will send that data to web server. If it is miss, then what cache has to do, cache has to go to database and inquire for the data or request the data from database. And database will send that data to cache. Cache will first update itself, step number 5, and then it will send data to web server. Okay, again I'm repeating. Web server will first inquire data to cache. If cache is available with the data, it will send it back to web server. Then story ends there itself. But if the cache doesn't have the data, the latest information, whatever data web server is asking for, then cache itself. Here we have seen in cache aside, web server will go to database, but in read through cache means we are going through the cache. That means cache will be in between, sitting between web server and database. So cache will go back to database, get the data, and data will be updated in cache, and then cache will send that data to web server. So point to remember that cache will first update itself. That means for the next request, cache will have that data with itself. So first, after receiving data from database, cache will update itself, and then it will send that data to the web server. All right. I hope these 2 points are clear, or these two strategies are clear. Let me then move to next strategy. So this is what we have seen is cache invalidation when we read the data. In both these cases, we are trying to read the information from cache. Okay. And because data is not available, cache hit or cache miss. In that case, how the system, see, this is again, this whoever is designing the system, they have to take care of this. And it again, case to case basis, whether you want cache to go to database and then update itself and then go back. There are advantage and disadvantages. Some of them we will look it into the next point so that you will have clarity on these 2 points as well. So let's look at some right strategy now. Okay. So here, right now, what we have seen is when we read the data, or how we do it, how we invalidate the cache. And right here, we can going to see is how when we write the data to database or cache, how we see to it that the cache is available with the latest information. So first strategy is again similar like read through cache. Here we are having a write strategy, which is called write through cache. I'm just adding word cache here because we are doing it writing through cache. So what web server will do? when it has to write the information, it will first write that information to cache, the step number one. And once that data is written to cache, cache will write that data to database immediately. First, it will write to itself and immediately it will send request to database and it will write that information even to the database. And then database will send, okay, after the information is written to the database will be sent an acknowledgement that yes, the written write information is successful. And then the cache will send response back to web server that yes, the operation is successful. So in this particular scenario, unless and until data is not written to both cache and database, the success message is not passed on to web server or to the user. Okay, in this case, again, I'm mentioning that you have to write data to cache, means you will write data first to the cache and cache will write the data to database, and then the acknowledgement will be sent back to web server. What is the advantage and disadvantage of this method is because the data is written to cache first. So any read requests that are coming into picture, they will get the latest information immediately from cache itself. It has to do, it doesn't have to go back to the database because we are writing it first to cache, so it can immediately send that data to servers which are trying to read that information. So the retrieval will be faster. And again, there will be strong consistency. I'll say there will be consistency between cache and database because data is written in both the places together. It is written to cache, it is also written to database. So they are consistent. Both will be consistent to each other. And even if anything happened to cache, or anything happen to database, data will be available at one location, either in cache or either in database. So failure will be there in any of these components, still the data will be available so that there will be no data loss. Okay. But only one disadvantage of this method is until and unless the data is not returned to both cache and database, user will not get response back. So till that time, user have to wait for the response. Mostly it is not minutes, it may be few seconds, but that response user will get with some delay. So there will be a kind of high latency will be there. So because response, you will get it with some more time, not quickly, not in milliseconds maybe. It depends on system to system again. So in this case, that is the only disadvantage because data is written in both. So it is going to take some time. Usually it is take time in databases if there's a SQL database working behind, or if there are multiple tables in it, so there are chances that it has to go to write to multiple tables, or maybe if the database is shard in the sense there are multiple uh, servers on which the database is split, and the data has to go to the multiple shards and get it. I mean, it has to get written, and then the response has to come back. Then it is a kind of expensive operation. Okay, that's why it may have higher latency. Moving around to the next strategy is write around cache. What does it mean? So let's look at it. What web server will do first is instead of writing the information to cache, it will first write the information to database. Okay. This web server is writing information to database. So database has the latest information. And suppose there is another user, like another web server is trying to read the data, or maybe same web server is trying to read the information, but it is reading from cache. It will check that same information I have written to database, whether it is available in cache or not. That may cause cache miss because the data is yet not available on the cache itself. So when database will send read request to cache doesn't have that data. Then what cache will do, it will read that data from database. And once that information is sent back from database to cache will be updated itself, and that data will send back to web server. So it is right around cache. Why it is mentioned this way? Because here data is first written to the database. And then whether the same web server or other web servers are looking for data from cache, the same data from cache, then cache will not have data because it is written to the database first. Then cache will acquire that data from database. It will receive that data. It will update itself and send that data back to the web server. Okay. So here nothing right around means nothing, but it is right now initially when we are writing the data, cache is not in picture. In first case, we have seen right through cache, means cache is in between of web server and database. So everything will go to cache first, whether it is coming from web server, whether it is going from database, it will be cache will be sitting in between. Well, in this case, web server is writing information to database, And then when cache will be inquired for the data, then it will read from database whatever latest information, and then it will send it back to web server. What will be the advantage of this? Again, cache, no, it has continuously, suppose the information is written to the cache itself. Cache will be flooded with the information or data or whatever right operation that are happening. And we don't want that to, means we don't want cache to get flooded because cache is not having that much of capacity like database. Okay, cache may be of 2 GB, 4 GB kind of capacity, or maybe more than that. But it again, cache is not like database. It's just the temporary memory. That's why it is not having enough space. Again, there is another point related to that, that what should we remove when there is no space available in cache. So that's a completely different topic. But just to mention, we don't want to cache to get flooded immediately. So that's why this kind of strategy come into picture, where data is usually written to database. So in this case, yes, the recently written data is not always available with the cache. It has to go back to database and get that information from database. Again, here, because we have to go roundabout, like go to cache, check the data is not available, go to database, get the data, and again come let that data come back to cache and then send back to web server. This again causing higher latency. Just like what we have seen here, right through, similar case will be here in the right around, where user will experience the higher latency. Okay. Now moving to next strategy, it is called write back cache. Write back. Here, data is constant. It is, you can see cache is constantly written with the new data. This constant write information is going on and on with cache. It will continuously, and what cache will do once the data is written, it will immediately send the feedback that yes, data is received or successful. Your write in operation is successful. So cache will first receive all the data, and it will immediately send that response that yes, data is written. And then after some time, maybe there is a some interval, some time interval in which cache will write this information to the database. This is after some time. Maybe there is a particular time that you have to decide when you are designing a system or when you design a cache in that after some time, maybe in 10 minutes, maybe an hour or something, you will write that cache data to the database. Okay, so that is called write back. Write back in the sense later on, you will write cache data to the database. Okay, here, what is the advantage? The response will be very quick. There will be low latency and high throughput. Immediately data is written to cache and immediate response is given to user. Whichever other web server is trying to read the information, they will immediately get the required information, the latest information. But there are chances that if the cache goes down, then there will be a data loss because there is a risk. Data is available with cache itself. The cache is sitting with the latest information. So far, it is not written to the database. And something happened to cache, then that data will be lost. But there are strategies through which you can also uh, achieve that data. Like the data loss can be restored back, get that data back. So there are some strategies. Maybe you have multiple cache which are replicated immediately. Maybe you have some mechanism through which the data can be restored back. I just told you one mechanism of having multiple cache, or the active and passive cache where data is written to both the cache. So these kind of strategies are there. It depends on system to system. Okay, but in this strategy, that will be only part that may cause some kind of data loss, or there will be a risk involved in it. Okay, so this is what about the right strategies, and this is all about read and write. I'll say both, and it all depends on system to system, that how you are designing a system and how you use this strategy depend on the different situations in your system. Okay, so that is all for today. Let me stop recording.